Okay, so now that we've got our booklet going pretty good, let's take a look at where we're at. So we've got our paper 1, and we've got our vocabulary section done. We've got our formulas in here, and we've got our prior knowledge ready to go. If you haven't done these already, you might want to go back and watch the other videos so that you kind of are caught up with us on where we are here. Oh, it looks like my outlier one is kind of, I might need to fix that one. Okay, and so now we're here. We're to the problems that we struggled with. So what I'm going to do is I'm going to take just a guess at the problems that I think you struggled with. And I'm going to start off and say, I don't think many of you struggled with problem number 1. And I'm going to take a shot in the dark here and say that I think the first one you might have struggled with might have been that problem number 2, which was the distance one. And so what I've done is I've just kind of printed these off a little bit. And I'm going to grab a pair of scissors, and I'm going to start off with problem number 1. So let me get my scissors, and I'm going to actually... Okay, so I've cut it out. Now, you can just write it in there if you want, but you can also cut it out. So this is my first problem, and this is one of the ones that had the coordinates on it, but it was also done with, like it had the coordinate grid, but it was in 3-dimensional space. And sometimes 3-dimensional space can be a little bit tricky to work with. So if you've got the ability to cut and paste and put these in your booklet, man, I would say go for it because it'll make it that much easier for you. Otherwise, just pause the video here and just write it in. So here we go. So I've got this right here. I'm going to move my test booklet over because I don't really need it anymore. And I'm just going to go over here and I'm going to, work this out. So here's what it says. What it wants us to do is we've got this ground level station here in this coordinate. And what the problem asks us to do is to find the distance between these stations. And so if you remember on this one, you had a picture. And so I'm going to kind of maybe draw it right here. This was number 2. And you kind of had that 3-dimensional space a little bit. And it kind of looks something like this. And you had these ordered pairs out 20, over 5, and up 250. So it was kind of up here. And then you had another one that was out 140, over 15, and up 0. So it was kind of like right here. And if you remember, it kind of looked like this blob, this little thing. And it was kind of over here, and it was like here. And it was kind of looking like this little blob of a mountain looking thing like that. Okay, let me see if I can zoom in. And so what we had to do was we had to go in here and we had to find this distance. And so one of the things that was pretty easy to do was to recognize you had these ordered pairs. And so we had the coordinate A at 140, 15, 0, and we had the coordinate B at 20, 5, and 250. And so one of the first things I did was I had to find the distance from A to B, right? So I simply wrote the distance equals the square root of, and then I did 140 minus 20 squared plus 15 minus 5 squared plus 0 minus 250 squared. Okay. And then I said that the distance equals, and you can put all that in your calculator and hit enter. And it's going to give you a really long number. Now I'm going to write it all out because remember with IB, we want to go ahead and write out a bunch of it. Like go ahead and write out as much of it as you can because that way if you mess up doing those sig figs, at least you'll get some points if you mess that up. So sig fig wise, we're going to look at the first 3, which is 270. And I'm going to look at this 7. I'm going to look at the 4. It's not going to change it, so I'm going to leave it at 7. And it was meters. So it's approximately 277 meters. That was my distance. And that was part A. But then the next thing it wanted me to do was it wanted me to find the midpoint between these, right? So on part B, all I had to do was find the midpoint. So remember for the midpoint, you take 140 plus 20 and you divide it in half. And then you take 15 plus 5, divide it by 2. and then you take 0 plus 250 and you divide it by 2. And that's going to give you the midpoint, which is 80, 10, and 125. Now, the last question basically wants you to do application and interpretation, R class. Write down the height of the station M in meters. The height. How tall is this station? You had to interpret that the height is Z. It's the Z axis. What's the Z? The Z was 125. So you had to be able to interpret that Z was 125 meters. And that's where a lot of people messed up on that one. All right. So let me get this back in order so I don't mess these up. All right. So the next one for sure, we're going to be cutting this one out because that surface area on this one, oh yeah, a lot of people really struggle with that. So if you want to pause and draw this one in, I'm actually going to cut it out and put it in. I'm going to try anyway. I'm going to try and cut this one out because you already know I can't draw this one because I already tried to draw this one a while ago. So here we go. So I'm going to take this one. I'm going to put some glue on it. And I'm going to put my picture. So I'll just put it right here. And again, you can do these however you want. This is just how I'm putting mine in here. I'm going to do number 3 right there. All right, so on this one, I've got a storage container. And basically, I just need to find the area of this container right here. So I'm going to say, what is the surface area? What is the surface area? Okay. The storage container consists of a box with a lid, and it's got everything labeled on here. The lid fits on top exactly. The total exterior surface area of the container. Okay, so let's just start off with pretty basic, right? We can do the rectangles. Those are pretty easy. So we could do, this is 42. This right here is 34, right? This is 34. And I've got a front and a back. So on here, I could say 42 times 34, the front times the back. And there's 2 of those, right? So I'm going to say times 2. Now I'm going to do the 2 sides. This is 90 times 34. So I'm going to do this. I'm going to say 90 times 34. And there are 2 of those. So hopefully you're following me. That is this right here and then this side right here. Okay. Then I've also got the bottom down here, which is 90 times 42. The base is 90 times 42. So 90 times 42. And I've only got one of those, so I'm just going to say times 1. All right. Now, I have already done the math on this, and so I'm going to just write down what I got. So I got 2856 here. I got 6120 when I multiplied here. And I got 3780 when I multiplied here. So that's the base. Now, I don't have to do the top piece right here because it's covered with the dome. But here's the thing. Now I have to do the lid. And there is not a formula in my formula chart for this lid. And that's where it gets a little bit tricky. You've got to have this prior knowledge to figure this out. So this is a cylinder, correct? And so I need to think about from here to here, what is that? And I believe it gave it to me somewhere, maybe. Or no, it didn't, did it? So you have to kind of know a little bit about this. The lid fit, let's see. And the lid in the shape of a half cylinder is shown in the diagram. The lid fits the top of the box exactly. The total exterior of the surface of the storage container is painted. Here's what you may not know. And I can't remember, somewhere I was thinking it said it. The container consists of a box with a 42, and the shape of a half cylinder is shown. oh, I thought it said it somewhere. Oh, well. This right here is half of this right here. This distance right here is going to be half of this. And so from here to here, again, that's going to be 21. So you need to find the area, the surface area, not the area, but the surface area of this cylinder. Okay. If you think about just this end right here and this end right here, the surface area of this end, I'm trying to color it here, this little piece right here on the end, that's like the area of this circle right here, right? And if you think about it, you've got the area of this little piece down here. This piece and this piece is like a whole circle, right? So if I add the area of this piece and this piece, the area, and I'm just working on the cylinder, I'm not looking at the bottom. The area would be pi r squared. And that's just this piece and this piece, just the end pieces. So the end piece would be pi times 21 squared. Okay, I am going to keep this in terms of pi until the very end because I want it to be accurate. 21 squared pi would be 441 pi. That is just the little pieces on the end. Now to find all of this surface area, think about, because they don't give you this in the formula booklet, you just got to like figure it out. Think about taking this little half circle right here and moving it up the cylinder. All the way up this, and like it's a little piece and you're just going to move it all the way up, piece, and you're only adding up this little rim right here. And you're taking this little rim and you're like stacking it on top of each other. It's like taking this piece of paper right here and you're stacking it on top, super, super tight, all the way up, and you're counting them all the way up. So you basically want to take the rim of this, which is 2 pi r, right? The circumference, 2 pi r, stack it on top of each other all the way up. So you need to take 2 pi r times the height, which is the height, right? The height is 90, right? So we need to go 2 pi r times 90. Oh, but there's one more piece, and this is the piece that caught so many people on this. It's 2 pi r, oh, but you only need half of it because it's half of a cylinder. So to get the surface area of just this little piece right here, so let's do the surface area of the half cylinder. I'm just going to write this. I'm going to just write it like that. We're going to take half of it because we only need half, times 2 pi r, that's going to be the circumference right here, times the height, because we got to stack those up all the way. Okay, so here we go. It's going to be 1/2 times 2 times pi times 21 times 90. So 1/2 times 2 times pi times 21 times 90. Okay, here's what this equals. When I multiplied that out, I got 1,890 pi. So I ended up with 441 pi and 1,890 pi. That's just the top. So I'm going to say that the cylinder, let's say the total cylinder, equals 441 pi plus 1,890 pi equals 2,331 pi. And now I'm going to put it all together. And since I'm kind of running out of room right here, I'm going to do this. I'm going to put this right here. I'm going to draw a line. And I'm going to come right here. I'm going to say the total surface area is approximately. Now, I'm going to take this right here. I'm going to take all of these. I'm going to add these together, plus this right here. Okay? So, 2856, and I'm going to write them right here. 2856 plus 6120 plus 3780 plus 2331 pi is approximately, and here's what I got. And I'm going to convert it all to decimals. I got, let's see, 20,079. Let me put, oh, I put too many zeros. I put 200. 20,000. 20,079.05248. But I want to put that in sig figs. But I'm going to go ahead and write it out because remember, we want to write it out. I'm going to say is approximately 20,000. Now I want to do 3 sig figs. So that's the first 3. 1, 2, 3. So I'm looking at this 2200. The 7, which is the 4th digit, the 7 would round the 0 to a 1. And then everything else would turn to zeros. And then I'm going to put centimeters. And it's surface area, so it would be squared. So there it is. That one was a tricky one. Okay. Let me take a look at number 4. I can't remember what 4 was. That the, oh yeah, that was the trig one. Okay, so number 4. Maybe 4 gave you issues. I'm not sure. Let me see if I can find my picture of number 4. I sure can. So I'm going to go ahead and put number 4 on here. And again, if 4 didn't give you any trouble, skip it and go to the next one. I'm going to go ahead and cut this one out. You're going to find that I'm probably going to be putting all of them on here. So you just skip to the ones that you need. All right, so number 4, let me get my glue. And I'm going to put it on there. If you want to go ahead and start drawing number 4 on yours so that you have it on there, go ahead and do that. I'm going to put that right here. Whoops. All right. So this is my number 4. Okay, so here we got to do on number 4. We've got this diagram, and what they want to do is write down the size of the angle of depression from H to C. The angle of depression. Oh my goodness. In order to do the angle of depression, remember you have to know that the angle of depression, you have to go across, and the angle of depression is going from here to here. Oh, that's right. So there was a lot we had to do on this one in order to figure that out. All right. So I'm going to see if I can remember how to do all this one. So let's see. I know I'm going to come across. I know that this was 25 and this was 90. So if this big triangle here was 25, then I know that from here to here would have been 65. 25, 90. That would have made that big angle there 65. Right? And that means if this is 65, this angle right here would have been 25. Now, one of the things, maybe you remember that these are alternate interior angles. Cut, like these lines right here would have been parallel. And so you'd be like, oh yeah, those are parallel lines. And so it was a fast find for you. Some of you wouldn't have remembered that. But anyway, so I would say the angle of depression equals 25 degrees. And again, there wasn't any like true math you're doing right there. You're just looking at it. And then for B, find the distance from A to C. So I had to find the distance from A right here to C. I knew that this right here was 380, and I knew that this was 25. So this is the adjacent side, right? I knew the opposite and I knew the angle. Opposite and adjacent. That sounds a whole lot like the tangent of 25 equals the opposite over the adjacent. So I just have to know how to solve that, right? I guess I could have put B there instead of AC. So I have to figure that out. So if I solve this, I would say, let's see, AC or B, whichever we do it, is approximately 380 divided by the tangent of 25. Now, I do want to be super careful that my calculator is in degrees and not in radians when I'm working this one. That would be a big taboo on this one. All right, so when I worked this one, I got 814.9126928. And I would shorten that sig figs and do 8, 1, 4, and the 9 would round the 4 to a 5. And it is meters. All right. So for part C, find the distance from B to C. B, okay, so now they just want to know the distance from B to C. So from B to C, we'll have to do be a little bit more careful, right? So let's see, from B to C. Well, you know the distance from here to here, but B to C, you might be thinking, well, there's no right angle, but there's still a right angle here. Could you find this distance here? And then you could just subtract, right? So change gears. Find from A to B. So let's find, this would be opposite. So let's do tangent of 40 equals 380 over AB. Tangent of 40. And so let's find AB is approximately 380 divided by tangent of 40. And let's get that approximation. When I did that, I got 452.8663632, I think, if my ink pen didn't run out, which is approximately 3 sig figs, 452, and I'm going to go to the 8. The 8's going to round the 2 to a 3, and meters. Now, that's not what I was trying to find, though. I wanted to find B to C. So I'm going to use my rounded numbers, and I'm going to say that AC minus AB would equal BC, correct? So AC was 815, minus A to B was 453, right? So if I do that math, which I haven't done yet on my calculator, I would say 815 minus 453 is 362. And it would be meters. All right, that was C, and D is the last one. Find Minta's speed in meters. So this will be D. I think this is going to be the last one I'm going to be able to get on here. What's my next one? I was going to see if I could fit them all on here. Oh, the box and whiskers. Yeah, I think I can get it all on here. I'm going to squeeze D over here because I think I can get the next one on here too. D. Okay, so find Minta's speed. You have to know on this one that distance equals rate times time. We should probably put that on our prior knowledge because like that for sure is something we need to already know. And that means that rate equals distance divided by time, Like, they don't give you that. You have to already know that. And that's kind of a bad time there. There we go. You have to know that. So the distance we went, Minta's right here, he went 362 meters. He went from here to here. So his rate, he went 362 meters from here to here is how far he went. And the time it took him to go there, they said it took him 15 minutes, right? So it took him 15 minutes to go that far. So his rate that he was traveling at when I do that, oh, I can't do 15 minutes though, can I? Because that was 15 minutes. And it said on this one, this was the kicker. This was the kicker on this one. This is why this problem got missed. It said, find Minta's speed in meters per hour. This is meters per minute. You have to convert that to 362. 15 is what part of an hour? Oh yeah, it's 1/4 of an hour. You have to convert this one to meters per hour. And that comes out to be 1,450 meters per hour. Yeah, I know. A lot of people missed that. So a lot of people got this part up here, but they missed that conversion of the hour. So you might even put a note here. Convert minutes to hours. Another put careful to watch for units, minutes, hours, and then we might say meters and kilometers. Because they'll do stuff like that. They will mix it up, and sometimes it'll be minutes, hours, kilometers to meters, and you just have to be super careful and pay attention to that. I thought we were going to be able to get more on that page, but because of that right there, I wanted to be sure we got that on there. So, super, super important. I'm going to actually go ahead and highlight that because I'm going to highlight the hours and the minutes on that one, and then I'm going to highlight those. Just because that's a tricky one. Oh, it's a tricky one. All right. So I do have those on there. And now I'm going to go ahead and go on to the next one. Yep. And I've got that one right there that I really need to fix right there. That outlier right there. Okay. So the next one is our box and whisker, number 5. So on our box and whisker, this one actually wasn't too bad, and I'm going to guess that a lot of you probably did not have trouble with this one. We've spent so much time on statistics that I'm going to guess that a lot of you probably nailed this one when you got to it. Now, I'm going to go ahead and do it, so if you need to skip this one, because you're like, oh, I got this one, Mrs. Dean, I don't need help on this one, feel free to not watch this one. All right, I'm getting ready to glue it in. This is number 5. There we go. If you want to watch it, you are free to watch it with me. Okay, so number 5, we've got a box and whisker. From this data, we just have to identify a couple of things. So I'm going to actually come over here. We have to identify the minimum number of 6 days. So you have to know how to read this. So we've got a spot right here, and I'm going to go ahead and put little tick marks on this. Because you notice when you're reading this, you're like, wait a minute, these aren't like, As you're looking at it, you're like, okay, this is not quite, everything's not exactly 1, is it? Because as you look at it, you're like, wait, that's a whole lot further. And so you do have to kind of go, okay, I'm not sure how these are going when you look at it. So when you start looking, you might even kind of go, okay, let me just count. So we're here, and then it's 1, 2, 3, 4, 5, 6. Oh, okay, if there's 6, so this is like 2, 4, 6, 8, 10, 12. Is that what we did there? So it's kind of like this is like 2, 3, 4, 5, 6, 7. Did I count that right? And then this one right here, that's going to be like, let's see. Oh, here's one right here. I'll make sure I did it right. So 5, skip 6, skip 7, skip 8. Yeah, it's every other one. Okay, so here's 5. Skip, this will be 6, skip 7, skip 8, skip 9, skip 10, skip 11, no, 12, sorry. That's 11, yeah, 11. That's 11. Skip 12, 13, skip 13, skip 14, skip 15. Okay, so 5, skip 4, skip 3, skip 2, so that's 2. 15, skip 16, skip 17, skip 18. Okay, there we go. I got them all labeled now. Trying to figure out how to label them is probably the worst part. I like it better when they just go 1, 2, 3, 4. Okay, so I got everything done. Everything's labeled, all my marks. So here we go. So the first one, A, says, what's the minimum number of sick days? So when I look at this, the minimum, you have to know that this is the minimum. This is our maximum. And in the middle right here, this is our median. So the minimum number of sick days, 2 days. And then the next one is the lower quartile. Q1 would be right here. That would be 6 days. Let me put that Q1. The median. Median's in the middle. That would be 8. Be sure you label it with days on there. All right, B. Paul claims that this box and whisker diagram can be used to infer that the percentage of employee who took fewer than six sick days is smaller than the percentage of employees who took more than 11 sick days. State whether he is correct. Well, fewer than 6 days. Okay, so let's write it like this. Fewer than 6 sick days. Okay, so let's write fewer than 6 sick days. This is what he says. That fewer than 6 sick days is less than the employees that took more than 11. Is fewer than the employee that took more than 11 days. Okay, that's what he says, right? They took the percentage of employees who took fewer than sick days is smaller than the percentage of employees who took more. So remember, each of these should be 25%, right? 6 days. Oh yeah, well here we go. Let's look. I can't say that. Each section is 25%. Remember, this is 25%. This box right here is 25%. This box right here is 25%. And this upper quartile right here is 25%. So, he's saying that fewer than 6 sick days. So this right here is 25% of the employees did this. So 25% is that right there. Is that less than the ones that took more than 11 days? Well, the ones that took more than 11 days is also 25%. Is 25% less than 25%? No. So that's not really true. They're actually the exact same percentages. So I would say this is not true. They are the same percentages. at 25% each. And the reason why is because they're each 25%. All right, I'm going to draw this off. And I'm going to go on to, and this problem right here was not missed by very many. Not application interpretations anyway, because you guys rock and roll on your statistics. All right, here we go. Number 6, we have a picture of a graph, and we are going to do a perpendicular bisector. So I'm going to put my graph on here. If you want to start drawing it on yours, or if you've got it and you can cut it out, you can do it that way too. Whichever way works for you. All right, I'm going to be gluing mine on while you are doing yours. Okay. This is number 6. Okay. On number 6, we have 2 schools represented by points A and B on the graph below the road. We've got this equation of a line. So let me put this equation of a line that we've got here. We've got negative x plus y equals 4. Okay? And what we know is that it passes near the school. So let me just go ahead. One of the first things I did on this one when I saw this is I went ahead and solved this, and I said y equals x plus 4. I just went ahead and solved that because it was just easier to go ahead and already have that. The architect is asked to determine the location of the new bus stop such that it has the same distance from the schools. So one of the things you have to do on this one is you have to find the equation of the perpendicular bisector of AB. So you know that point A is at the point, because it gives you 220, and it gives you that the point B is at the point 1424. If you're going to find the perpendicular bisector, you have to find the midpoint of AB. So right off the bat, let's find the midpoint. So let's take 14 plus 2, and then let's take 24 plus 20 and divide it by 2. So that midpoint of AB is going to be at the ordered pair 822. Okay. If I were to try to graph that at 822, it's going to be 8. It's about right there. It doesn't really look like it's the midpoint on my graph. I mean, I'm sure it is, but it does kind of look like it's off a little bit because it's not drawn to scale. So it's a little bit off, but anyway, it's there. Okay, so find the equation of the perpendicular bisector. There's the midpoint. In order to find the perpendicular bisector, you also have to have the slope of the line that passes through these points. So I'm going to do this as well. I'm going to take this and I'm going to graph the line that goes through there. And then 8, let me see if I can do this too. 8. I'm going to go right here. There it is. 822 is right there. Not the best, but anyway. Okay, let's find the slope of AB. So if I want to find the slope of AB, I'll do 24 minus 20 over 14 minus 2. Okay, so the slope is going to be 1/3. Now remember, I have to do the perpendicular slope. So in order to do the perpendicular slope, I'm going to have to flip it and switch it. So I'm going to take 3 and I'm going to say the slope of the perpendicular, I'm going to flip it, which is 3, and I'm going to switch it and make it negative. So here is the perpendicular slope. To write the equation of that line, I'm going to have to do, I'm going to come back up here, y minus y1 equals the slope times x minus x1. I've got the point and the slope, just going to plug it in. So y minus 22 equals negative 3 times x minus 8. I'm going to simplify all that, and here's what I got. Y equals negative 3x plus 46. Now that's a whole lot of math right there that I didn't do, but I feel like you can do that math with me. Y minus 22 equals negative 3x plus 24. Move that 22 to the other side, combined, and you get 46. All right, so that means the slope, or the equation of this line right here is y equals negative 3x plus 46. That is the equation of the perpendicular, I'm sorry, that's the equation of the perpendicular bisector. Now what it wants is determine the coordinates of R where the bus stop should be located. All right. So let me go back because I don't remember where R was. A road R represents by R this is the equation that passes near the school. Okay. So here's what I need to know. I need for this line right here and this line right here, I need to know where do these two lines intersect. Because basically, I've got my perpendicular bisector that goes here. This is my perpendicular bisector. That's this line. It goes here. There it is, right there, right there. Okay. The equation of this line right here, I'm going to call this y equals x plus 4. There's a point right here where this line right here, this line is y equals negative 3x plus 46. I know it looks vertical, but it's not. This line right here, this point right here, that's the bus stop. That's R. I need to know what's that point R. Where do those lines intersect? So you can do it a couple different ways. You could use your graphing calculator. You could calculate where they intersect. You could also simply set them equal to each other, which is what I did. I just said negative 3x plus 46 equals, I took this one, and then I just set it equal to the other one. I just said equals x plus 4. I just went back old school, did it that way. And so I subtracted x from both sides. And so I did negative 4x, and then I subtracted 46 from both sides and got negative 42. And then I divided both sides by 4. And so that gave me x equals 10.5. I substituted that back in. You could go either spot here or here. And that gave me y equals, and I got 14.5. The question was, determine the coordinates of the point R where the bus stop should be located. So I'm going to say R, and I'm going to say 10.5, comma 14.5. That is where the bus stop should be located. And that one, wasn't a super difficult one, but I mean, the numbers aren't pretty, and so sometimes when you don't get pretty numbers, you're like, did I get that one wrong? Don't fret, because a lot of times you're going to get those decimal points when you are working these. Like, that's just kind of normal. All right, I'm going to draw a line on this one, and I've got that word outlier that's driving me crazy because it's in the wrong spot. I need to move it. Okay, I'm just going to draw that right underneath it. I'll fix that later. All right, on to number 7, which is that equation. Okay, so this one, oh my goodness, y'all. So this one was not, like, it had all kinds of issues. That's what I'm going to say on this one. We had so many people miss this one because they thought it was taking the derivative, and it wasn't taking the derivative. It was simply taking it and, like, Yeah, people thought they were taking the derivative, and you weren't taking the derivative. And then we were really sad because you weren't taking a derivative. All right, let's see what we can do. All right, number 7. All right, here we go. The function is defined by that. Find for -7 less than or equal to x is less than 7. Oops, where'd he go? There he is. Okay. For this function, we want to find the range. First thing I'm going to do on this one is I'm just going to come over here and I'm going to graph it. So I'm going to come over here. And now I only need to look at this range from -7 to 7. So what I want to do is graph it from -7 to 7. That's the only thing I need to look at. So I'm going to go up here. Okay. And I'm going to plug this in. I'm going to say 2 minus, and I'm going to do 12 over x plus 5. I'm going to do my window, and I'm going to go from, actually that's a pretty good window right there. Let me just graph it. Okay, so I can kind of see it right there, right? Okay, so over here, it's kind of doing something like that. And over here, it's just kind of doing something like that, right? Oh, it does look like it crosses a little lower, but I'll go back and figure that one out. Okay, so it's kind of doing something interesting like that. This is going down to -infinity. It's going over this way. It's going this way. And it's going this way. Okay, so I want to do the range. Okay, so let me do this. Let me go to Windows. Let me do the minimum x. Let me actually put in -7. The maximum x, let me put in 7, right? Yes. And let me graph it that way. On the window for the y, let me make the y go bigger. Let me put in, let's put in -20, and let's put in 20 there, so we can get a little bit bigger. Just so we can see it a little better. Okay, so this is the actual. So on this, when I look at this, this helps me see it a little bit better. On A, and there's a lot of different notations that you can use on this. They give us so many different options. I am looking at the range on this. So I'm looking at the y values. On the y values on this, I need to be thinking about this. What is the range on the y? Well, it goes up for forever, right? And it goes down for forever. But the problem is there's definitely an asymptote in here, right? And the asymptote's right here at 5 because it can't be 5. X cannot be +5, -5. Like, what happens right in here? And you can maybe go here and kind of see, do we have an error anywhere? Well, here at -5, we know we've got an error there. But what happens when X is, do we have any other ones? Okay, at 1, when X is 1, we have a 0 right there. Y is 0. And then it goes from -infinity. Oh, sorry. Let's go back up here to look. I was trying to look at some of these other ones because it's definitely got these asymptotes right here at 2. I want to go in here. I'm going to graph y equals 2 so we can see it. There it is. At y equals 2, and here it is right here. When y is 2, it never touches it, right? That's where that asymptote is right there. It gets really, really, really close. And you can see it on the table too, because it never gets to 2. That y value is kind of looking to see if we can see where it is. It's going to jump over it. I was looking to see if we actually get to +2. I saw -2. I don't think we'll ever see it. because it's got that asymptote right there. And so here's what I'm looking at. I'm going to say, okay, it's going to go from negative infinity this way, right? It's coming down here. It's coming up and up and up. And it's going to get really, really close to what value here. And then it's got this big break. And then it's going to jump back up. And so I have to account for it on that one. And I'm trying to think how I want to do that. Oh, I know what I could do. Yeah, that's what I was doing. I was looking to see how I did it on my other one. And here's what I did. I actually labeled these endpoints. I did this on my other one. So since I was going from negative, that's the way I did it, because I'm like, I feel like I'm chasing rabbits here. I did this when I did it before. I did -7, and then I did, since I only went over here to right here at 7, that's what I did. I was like, where am I? I'm not getting anywhere with this problem. I'm chasing rabbits. Okay, that's what I did. Let me go up here. Since I only went out to -7, I did this. -7, 8. And then I did this. 7, 1. Okay. That's what I did. Okay, so let's do this. Let's cover that up. Let's cover that up. Okay, now it's a little easier to see. Actually, it's a little harder. Let me do this. Let me Okay. So imagine this picture looks like this now. Okay. We're only going from -7 to 7. So the graph starts here at -7, 8, goes up, and it goes from 7, 1. Here's my range. Now it makes sense. It goes down this way for forever, right? And it goes up, up, up here for forever. So starting on the left, this goes to positive infinity, right? Negative infinity. But start with your lowest value. Negative infinity, and it goes all the way up to, what's the highest y value? It goes up to 1. Let me get my, okay. So think about it this way. We're going to start down here. We're going to go all the way up to 1. And then there's a break. And then we go to 8. And we go all the way up to positive infinity. That's our break. And we go up to positive infinity. And this was negative infinity. So we're going to go from negative infinity all the way up to 1. And we actually touch 1. And we're going to union that. And we're going to start at 8. And we're going to go all the way up to positive infinity. But we're not going to reach it because you can't reach it. That is one way to write it. There are other ways to write it. We could say something like y is less than or equal to 1. And then we could say union that with y is greater than or equal to 8. We could write something like that. But you just want to be sure that you're writing. I don't think it mattered. Yeah, as long as we did a union, I think you could write it either way on that one. Okay, B. Find the inverse. Okay, this one, when it says find f inverse of x, that is how you read that. Find f inverse of x. And then we had to find f inverse. We had to find f inverse of 0. Okay, so right now we've got y equals 2 minus 12 over x plus 5. That's what we've got. Now to find the inverse, we're going to swap it. We're going to say x equals 2 minus 12 over y plus 5. That is one way to do it, and that's probably the more complicated way to do it. We could solve it. But remember, when you're doing the inverse, the other way to do it is simply to go to my calculator, Let me go here and let me clear that out. I didn't really have to do all that. And I'm going to do this. I'm going to put, well, I'm going to label a couple of these. I'm going to say 0, -2/5, 1, 0, 2, 2/7, 3, 1/2. Okay, I'm just going to label a couple of them, okay? But I want to make sure that I have 0 on both sides. It's usually just a little easier for me. This is f of x. F inverse of x is simply where you take the x and the y and you swap the sides, okay? So we're going to put 0, and we're going to put the 1, the 2, and the 3, and then we're going to put -2/5, the 0, and then the 2/7, and the 1/2. We're going to flip it on the other side. So f inverse of 0, I kind of got it off a little bit, is going to be 0, 1. So that means f inverse of 0 is 1. So we're going to say f inverse of 0 is 1. That's one way to do it. The other way is to finish the math that I started right here, which is to finish solving this. So I would say x minus 2 equals -12 over y plus 5. I think I'm just going to cross multiply. Is that what I want to do on this one? Yeah, I think I will. X minus 2 times y plus 5 equals -12. I'm going to divide both sides by x minus 2. Y plus 5 equals -12 over x minus 2. And then I'm going to subtract 5 from both sides. So y equals -12 over x minus 2 minus 5. And then in order to find, this would be f of -1, f inverse of x equals -12 over x minus 2 minus 5. I would find f inverse of 0 equals -12 times 0 minus 2 minus 1 minus 5. Oh my goodness, I can't even say my numbers tonight. F inverse of 0 equals -12 over -2 minus 5, which equals -12 divided by -2 would be 6. 6 minus 5 is 1. F inverse of 0 is 1, which is what we got there. All right, that is two different ways to do it. One is where you just find the f of x, swap the sides. I just didn't do a very good job writing them on the opposite side. You just simply swap them here. But if it works out where you can just swap them and see it, then it's a whole lot faster. All right. When they give you the domain and the range on this one, just remember that watch what they're telling you here. So I want to just highlight this one. I know this was a tricky one. Pay attention here because that was super important here that we label those domains and range. All right, we are at an hour, so I'm going to go ahead and stop our video here, and then I'll continue on again.